Hello, algebra students. Mr. Lawrence here, and today we're going to do some application problems. We're getting close to the test. Um, let's just get down to it. All right, we've got a story problem here about Bob starts a lemonade stand. To purchase the supplies, he spends $10. He decides that he will charge $50 per cup of lemonade. Now, the trick on these problems, these are super duper easy. The problem is you need to think algebraically, not the way you want to do it, because the way you want to do it is limited and will only help you figure out certain situations. Okay, if you do it algebraically, you'll be able to figure out almost any situation that is linear. Well, actually, you will be able to figure out any linear situation. All right, so there's some really, really important information in this story. The first thing that's really important is that he spends $10 of his own money. Yeah, to make money, you have to have money. Well, Bob needed $10 to buy the supplies to make the lemonade. Okay, that's a very important idea. Hopefully, you're thinking algebra. And 50 cents per cup of lemonade. Okay, 50 cents per cup. Those are two extremely important ideas. If you know what those two ideas are, and I'm avoiding telling you right now, this is an easy, easy problem. Before I tell you, we are going to start with the 50 cents per cup. Let's talk for a minute here about other things that sound like per. I don't mean your cat. You go to the gas station and it might cost $3.25 per gallon. A gallon of milk might be $1.29 per gallon. Whenever you hear per, you should be thinking ratio, right? A ratio like there are 2 boys per every 3 girls. You might say for 3 girls, but it can also be per. A ratio. Well, haven't we been using a ratio for quite a while here? Maybe the past week or two? Didn't our ratio, wasn't it the rise over the run? Isn't that a ratio? I mean, can't we write fractions as, or ratios as fractions, right? So when I say 50 cents per cup, I've got a ratio. And hopefully you're thinking, oh, you have your slope. Of course I do. I'm going to rise 50 cents for every 1 cup I sell. Then I'm going to rise 50 cents more for the next cup, and then 50 cents more, and then 50 cents more. Okay, so we know our slope. Our slope is 0.50 over 1. Now, somebody's probably wondering, could I just use a half? Yeah, I think you could use a half because you're going to go up $1 for every 2 cups, right? And so 1/2 would probably be easier to graph depending on the situation. Okay, now this $10. Well, ask yourself this question, answer this question for me. Before Bob has sold any lemonade, how much money has he made? And if you're thinking $0, you're not thinking, because Bob spent $10 of his own money. So at 0 cups, Bob has made -$10. I just gave you the coordinates of a point. 0, -10. Hey, where is that point? Yeah, it's on the y-axis. This is the y-intercept. This is B. Yeah, -10 is B. So part A asks us to write a linear equation that could be used to determine how much money Bob has made based on how many cups he has sold. Well, I'll define my variables first. I'm going to let y equal, let y, sorry, I got too many equals in there. Let y equal the money made, and x is going to be the number of cups sold. Well, if that's the case, then y is going to equal 0.50x minus 10, right? Now I'll keep this one in the back of my mind. When I get to my actual graph, I'll decide which one will be easier, more friendly to use. but they do mean the same thing because 50 cents and a half of a dollar are the same thing. Okay, hold on one second. Sorry about that. Okay, so now we have to use our equation to determine how many cups Bob needs to sell in order to make a profit. Well, let's go ahead and graph it. I think I'm going to use that one. And notice my graph is looking different. I didn't use a full 4-quadrant graph because one, it's impossible to sell a negative number of cups. So I didn't consider any number of cups less than 0. Okay, well, based on our equation, when Bob has not sold any cups, he's made negative $10. So I'm going to plot that point first. And notice on the y-axis, I'm counting by ones, but on the x-axis, I am counting by twos. So let's see, 4, 5, 6, 7, 8, 9, 10, I think is right about there. Okay, and I'm going to make that look like a point so that you don't get confused, and maybe I should make it just a little bit smaller. There we go, that looks a little bit better. Okay, so let me fill it in. There we go, that looks pretty good. Okay, and I'll tell you what, I'm going to clone him. All right, so now I know that actually, you know what? I think I'm going to use the 1/2, like I said. I said I was going to use the 50 cents, but I'm going to use the 1/2. For every 1 cup he sells, he makes $2. Some of you are thinking, Mr. Lawrence, he just went up 1 and over 1. No, I went over 2 because I'm counting by 2's on the x-axis. And so my graph is going to look like this, right? Or each little point represents the amount of money he's made. He hasn't even made any money. He's still in the whole $5 here. He sold 10 cups and he's still in the whole $5. I hope he has a good day for his sales, because if he didn't have a good day for his sales, he's gonna lose money. All right, so I'm not actually going to draw a line. I'm only going to draw a ray this time. And it's off a teeny bit because of human error, but let's see if I can make it look a little bit better. Oh, you know what, maybe if I just made it a little bit thinner. Change the color. There we go. Okay, so the question is, when does Bob make a profit? Well, hopefully you realize that this point right here is a very, very important point. Okay, can you tell me what that is? That's the break-even point. At that point, Bob has made $0. $0 made. Okay, well, how many cups is that? Let's see. 12, 14, 16, 18, 20. That's the point. 20, 0. And he's made $0, right? Now, I know most of you could have figured that out just, by doing a little arithmetic, but we have to be able to do this algebraically. So at $0 made, took him 20 cups to get there. When does he make a profit? He starts to make a profit at 21 or more cups. Because as soon as you get to here, now all of a sudden we're in the positive money. 21 cups, it looks like you'd make about 50 cents. Okay, 22, 24, 26 cups right here. At 26 cups, he's made $3. All right, so that's the first example. We're going to do one more example. The whole trick is thinking about it algebraically and not arithmetically. All right, Sheila has a lemonade stand to start her lemonade. Hold on a second, my music has stopped here. Oh, I'm in drama. You guys are watching me do this. It's a waste of your time. Okay, Sheila's a lemonade stand. Started a lemonade stand. She spent $14. Whoop, she's spending money. Sounds like a starting point. Sounds like a y-intercept. So that's B. Plans on charging $1.25 per cup. Okay, that's my slope. How do I know? Per cup. Heathcliff, who lives across the street from her, is also selling lemonade. Sounds like they're competing against each other. To start his stand, Heathcliff spent $16. There you go, y-intercept. He is planning on charging $1.50 per cup. There's his slope. Okay, write and graph a linear equation for each person. Well, I'll do Heathcliff first because I'm in blue. And again, my variables, I need to define them. For both of them, it's going to be let x equal the number of cups sold, and y is going to equal the money made. So Heathcliff's equation would be y equals 1.50, $1.50 x minus 16 because he spent $16 of his own money. Now, I might go ahead and say y is going to equal 3 over 2x minus 16. Remember, in the last one, it was a lot easier to graph one, um, 1/2 than it was 50 cents. Okay, for Sheila, let's see how much Sheila spends. $14 and $1.25 per cup. So Sheila's equation is going to be this, or 1.25 would be the same as 1 1/4 or 5/4 x minus 14. Okay, so now I'm going to need to graph these, and then I'll go to part B. So let me see here. I should bring these equations down with me. I think I'm probably going to end up using these. They're easier to use, if maybe not easy to move, but they are easier to use. There we go. So I'm going to bring those down to a graph I have waiting. And notice on this one that, I have a lot down there because we're going past 10, so it's going to get pretty small. My origin is here. Okay, this axis is my money made. And this, of course, again, is the number of cups sold. So let me find Sheila. I think I'm going to try to count by ones in this one. I think it'll be easier. So let me see here. Sheila, I need a negative 14 and then 5/4. So let's see here. 1, 2, 3, 4, 5. That might be helpful if I kind of mark. That's a negative 5, of course. 1, 2, 3, 4, 5. That would be negative 10. And then 1, 2, 3, 4, 5 would be negative 15. So Sheila's going to start right there. And then her graph is going to go rise 5 and run 4. All right, so we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, and then we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, and I'll do one more just to make it pretty. So I got to go 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, let me get a ray for Sheila. There we go. And I'm going to make that go a little bit longer. And I think Sheila's a Buckeye fan, so we'll make her line gray. All right. Now the other person. So Heathcliff, negative 16, he's going to start at. So negative 16 would be here. And then what was he? 3/2, I think. Yeah, 3/2. So we're going to sorry about that. Okay, so we're going to go 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2. I can't see what I'm doing. Put it right there. And then let's see, 1, 2, 3, 1, 2. They cross there, don't they? That's important. We'll talk about that in a second. Oh, I don't want all. I want this. And there we go. And I guess I can make it go longer, just like Sheila's does. All right, and let's see here. There we go. Make it a green color. We got gray and we got green. We got OSU versus Michigan State. Okay, so there's our graphs. We can tell that they're crossing the x-axis here. And here, it looks like they're off a little bit, right? So we could try to figure out what those, oops. There we go. What those points are, just by counting, of course. We know we're counting by ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's 10 cups. And 1, 2, 3, 4, 5. 15 cups. It looks like they're going to make a profit after they sell 11 cups. That gray one looks like it's crossing. No, it looks like it's off a little bit. Maybe it's just more than 11. Looks like the green one won't make a profit until they sell their 11th cup. Okay. 11 cups for profit. Right? See, because 11 would be right here. Okay, now it looks like this one might actually have to go 12 cups for a profit. It looks like it's off by just a bit. I know it's not hitting exactly because it's hitting this point exactly. That line got moved. I had it graphed pretty well, but I accidentally moved it. So let's see if I can, yeah, that looks better. It looks like it's hitting better. And see, at 11 cups, they're still going to be short a small amount of money. So it's at the 12th cup when they actually have made a whole dollar. Okay, whereas the green one will have made, 12 cups will have made, looks like maybe $2. Okay, so use your graph to determine when Heathcliff has made more money, when Sheila has made more money, if there's a time when they make the same amount of money. Well, you know what? Let's start with that same amount of money one. That's the important one. Remember I noticed, I drew attention to the fact that they crossed at this point right here? That's the place where they've made the same amount of money. Okay, so they've made the same amount of money, and you'll write this in sentence. I may not write it out on here, but this is what, 6, 7, 8. Okay, at 8 cups sold, money is the same. See, both of them have lost $4 when they've sold 8 cups. Okay, now when is Heathcliff ahead and when is Sheila ahead? Well, let's see. The blue one is Heathcliff, so that's the green line. Okay, so I'm going to highlight in blue when the green one is making more money. And that would be all of this, wouldn't it? Whoa. Okay, let me see if I can thin that out a little bit. That's a little too thin. There we go. So all of that, including this part here, right? So everything from there up is where Heathcliff has more money. How do I know? Well, the green line is higher up on the y-axis than the gray line. Now, for when has Sheila made more money? Well, her line is above the green line here. So when Sheila is when sales are slow or first starting, Sheila has lost less money. Well, she started off spending less money. Maybe Bob can afford to charge more or Heathcliff can charge more because his lemonade tastes better. I don't know, maybe. Okay, so there's two examples of what we need to do. Everything was based on the graph. We found our slope, we found our y-intercept, we graph them. And if there's more than one equation involved, we find the place they cross. That's the place where things are equal. And then we determined when things were greater for the one equation and when they were greater for the other equation. Okay, so we're going to get some practice with this on Monday. And I think we're going to sign off. Mr. Lawrence saying good night, everybody.